Hello and welcome to my channel. I am the Mad Computer Scientist. If you are new here, please take a minute to hit the like button. If you find this content useful, please subscribe and ring the notification bell. If you have ideas for topics you would like me to cover, whether they be math or computer science, please let me know below in the comments section. Today we are going to discuss multiplying binomials using something known as the box method. It is not the only method for multiplying binomials because many older people probably learned a method known as FOIL exclusively. The difference is this gives us a graphical way to organize our information, which may be easier for some people. I will have another video on the FOIL method itself. You are probably wondering, when do we use this method? Or when do we multiply binomials? And those are good questions. I would encourage you to look up more applications on your own, because the one I found was a construction application that involved finding the surface area of a swimming pool, where if the measurements are given in the form of one side has a measurement of 5 meters longer than some unknown value, and the other side has a measurement that's 3 meters less than some unknown value. This would indeed be an application of multiplying binomials. It is also probably something you're going to find in an algebraic word problem. By the way, if you actually do study construction, you will have to learn quite a bit of trigonometry. When we use the box method, we start out by drawing a box. I haven't drawn a box here, instead I've made a table in PowerPoint. This particular table has 9 squares and we're going to use 8 of them, and the only one that isn't going to be used is the top left purple box. Once we have drawn the box, we're going to write one of the binomials on the top. Which binomial we choose doesn't matter, we just have to include both of them. If you have taken biology and studied some form of genetics, you've probably recognized this is actually similar to what you do for a Punnett square, and it's going to work a lot like that. When we write the binomial, though, we have to include the signs because they are important and do affect our results. After we've finished writing the binomial on the top, we have to write the other binomial along the side. And thus we get something that looks like this here. Note that I've remembered to include the signs in this section as well. If you remember your multiplication, this is important because if we multiply two numbers of different signs, we get a negative number. If we multiply two numbers of the same sign, we get a positive number. When we use the box method, we're going to proceed from the top left to the bottom right. It really doesn't matter which order you do it in so long as you do all of them. So the way I'm doing it, we're going to multiply x times x, and as you probably know, that is x squared. After we're done with that, I'm going to move on to the top right. In this case, we're multiplying positive 3 times 3, which is positive 3x. I'm going to include the sign there, and you're going to see why it's important later. We'll do the same thing in the bottom left square, and we're going to remember the sign. X times negative 3 is negative 3x. And to finish up the multiplication portion of this, we're going to multiply 3 times negative 3, which you probably know is negative 9. Now we have everything we need to actually put everything together, so let's combine like terms. We combine like terms, and we're going to write the equation out here just so we can see what it looks like. If we combine all these terms together, we have an expression that is x squared plus 3x minus 9. And I know I said equation that is incorrect. It's not an equation until it equals something. In this case, we simply have an expression. We are going to finish this process by combining all the terms that are alike and can be combined. In this case, we can combine positive 3x minus 3x. And when we do that, we simply get 0. So we can rewrite the expression as x squared minus 9. And we have finished using the box method to multiply this binomial. Mad computer scientist, there was an easier way to do this. Why didn't you use the difference of squares pattern? That is a good observation, and I will answer it this way. I simply wanted to be able to check my work. I knew it fit into the difference of squares pattern, and I knew that x squared minus 9 does indeed factor to x plus 3 times x minus 3. And if we want to check that again, we can multiply it back out and we will get x squared minus 9. To use this, all we have to do is multiply the first term of each binomial, the second term of each binomial, and if it's a difference of squares, the middle term should be a sign. We can use this to factor the problem as well. If we have something like x squared minus 25, we can factor that out and get x plus 5, x minus 5. You can check my math on that by using the box method or the difference of squares pattern I just showed you. Thanks for watching. As you know, I like to end these videos with a math problem. Today we're going to do one I pulled from Twitter. We have 2 to the third power times 2 squared in parentheses times 2 to the fifth all over 2 to the eighth. Now, as a computer scientist, I probably know a lot of powers of 2 just by memory, and that does mean I can tell you what the answer to this problem will be just by working all of that out. I'm not going to do it that way, nor should you. We can use the laws of exponents to make this problem simpler. So the first thing using the laws of exponents we're going to do is add 3 plus 2 in the parentheses. That will make the expression 2 to the fifth times 2 to the fifth all over 2 to the eighth. Because of the associative property, we can drop the parentheses. Now what we're going to do is repeat the addition step we used in the first step and add 5 plus 5 together. So 2 to the fifth times 2 to the fifth equals 2 to the 10th. That gives us 2 to the 10th minus 2 to the 8th. Now what do we do when we have a fraction with two terms of the same base? Well, we're going to subtract the numerator from the denominator, as the rules of exponents allow us to do. This gives us 2 squared, which equals 4. If you wish to work this out on a calculator, you would eventually wind up with 1024 divided by 256, which does in fact equal 4. Please remember to do all the things I said at the beginning of the video. And I hope you all have a good day and found this useful. By the way, the next topic I have planned is choosing your first programming language for the new programmer.